the correct order of increasing acid strength of the compounds. These basically are the compounds, right? And these are the order givens. Now, acid strength, if I talk about, let us suppose all these are carboxylic acid. If I talk about the acid strength, then this is a general carboxylic acid. And when this dissociates and basically it gives acidity, these two are formed. Now, the acidity of this compound is determined by the stability of RCOO minus, right? That means more stable this compound will be, more acidic will be this acid, right? So that means if this is the ion, right? If R has an electron withdrawing nature, that means if it withdraws the electrons, right? So that means this will be withdrawn. So that means negative charge will get reduced, which will make it more stable, right? So that means electron withdrawing makes it more stable, while electron donating groups makes it less stable, right? So now let us see what are basically the compounds. First is A is CH3 C double bond O OH, right? Now if I talk about CHOO minus, and if I remove this compound, let's just remove this, right? So what is happening over here? CH3 is having a plus I effect, right? So that means it is decreasing the basicity, right? So it will be decreasing the acidity. So that means it will not be so much stable, because already oxygen is having a negative charge and CH3 is increasing the electron density, right? Now if I talk about the second compound, it is CH3O CH2 C double bond OH, O minus rather, right? Now what will happen over here? Although CH2 has a plus I effect, but since oxygen is an electronegative compound, it will attract the electron density. That means the plus I effect of CH2 will not be so much effective, right? So that means B will always be what? More acidic as compared to A, because this compound is relatively stable as compared to A. This is basically called the conjugate base, right? So the conjugate base in B is more stable as compared to A. That means B will be more acidic than A, right? Now let us come to the options again. So what are they saying? B is more than A. B part is also saying B is more than A. C is saying A is more than B, which is definitely wrong, right? And this is also saying B is more than A, right? Now, so we have eliminated one option. Now let us come to the C part, which is saying CF3, F, C double bond O, O minus, right? Now CF3 has a minus I effect, because 3 fluorine atoms, which are highly electronegative, are connected to the carbon atom, and they attract the electron density towards themselves. So CF3 effectively has a minus I effect. That means C is more acidic as compared to both B and A. So let us see the options again. C is more than B more than A. C is more than B more than A. But D part is saying B is more than C. So that means definitely D is wrong, right? Now we are left with 2 options. Now let us see the D part as well. It is saying COOH, and it is having CH3 and CH3. Now this compound has a very nice plus I effect. Very nice as in good plus I effect, because these two CH3 compounds also have a plus I effect, which are increasing the plus I effect even more of this CH compound. That means this compound is least acidic. Why? Because if we draw this one, the conjugate base, this will be least stable. If this is least stable, that means this compound will be less acidic, right? So that means D should be least acidic. That means option A is correct.